Hello. So, I'm Steven, and this is Valentin. This is a talk about the debugger. There has not been a formal talk on the debugger since ESUG 2019. And so we did a lot since then. And a lot of what we did is invisible work. And we cannot say everything. So this will be a two-part talk where, so I want to explain why we are working on debugger and how we work on debugger, who work on the debugger. So we are driven by research, and this is what I'm trying to explain. And in this context, I will summarize some of the biggest improvements we did the last years. And we'll finish by a demonstration by Valentin about how to extend the debuggers with what we call sometimes extensions of and plugins. And we cannot show you everything that we did, so we'll do more demos this evening at the TIC Awards. So we are doing research, and basically we want to build better debugging tools and give them to you. So that's why we work on the debugger. What we work on is globally that we are interested in exploring time traveling and object-centric debuggers and everything that we need on the language level to build those debuggers. For example, reflection. Our research method is not original. We observe facts and define hypotheses. We design solution. We build those solutions into Pharo, and in this process, we have to improve the Pharo debugger because this is our tool, our sandbox to experiment prototypes. Then we evaluate those tools empirically, and it does this research loop. But what's important is that we need to have the best possible baseline debugger, so that when we build a prototype, we can evaluate it, compare it with the best possible debugger that you, as for developers, use every day. And so this is why we have to contribute a lot and to improve the baseline debugger as much as we can. And then, well, we need help because when we build prototypes, we need the people who know the standard debugger to help us try to compare the new prototypes with the debugger that you use every day. Sorry. So, if you participate in one of our experiments, I just want to summarize what you should expect. So, if you want to participate, you can participate to surveys and interviews. You can also participate to practical experiments. There are three kinds of experiments that we do. In the first one, we divide the participants into two groups. The first group use the standard Pharo tools to solve a set of bugs, and then we collect data. And the second group use the prototypes, solve the same bugs, and then we compare the data. We try to see if one is better than the other and try to understand why. That means that you can participate to one of our experiments, and you will never see any new prototype. You will always use the debugger that you use every day. In another kind of experiment, you will use both debuggers. You will first solve bugs with the normal debuggers and then use a prototype to solve an equivalent set of bugs, and then again we compare data. And finally, there is another kind of experiment where someday you open Pharo, you have a pop-up that asks you if you want to participate in an experiment. If you click yes, it loads the tool, and then you live your normal daily developer life, and it collects data from time to time. This data is collected to a secure server at INRIA, and it's anonymous. So once the data is in, you cannot reclaim it, we cannot remove it, because we cannot find which one is your data. In the next weeks, in September, we will start such empirical experiments. One about what we call debugger-driven development or extreme test-driven development. For us, it's more or less the same. An experiment on object-centric debugging, and an experiment on a novel technique that combines time-traveling debuggers and object-centric debuggers. So I invite you to participate to those experiments if you develop with Pharo. Who's working on that? There's me, I'm a researcher at the EVREF team. There is Adrien, who is an engineer and who did most of the work on the Debugger last year, and Valentin, who is a PhD student working in our team. And I would like to thank Thales, Schmidt, and the French National Research Agency for funding Adrien, who really did most of the work. And without him, last year, the debugger would not have improved that much. On a side note, we are still looking for funding on the debugger. So if you want to contribute, you can talk to us. So this was what we do, why we do that, and who we are. Now, what changed since 2020? A lot of bug fixes, a lot of tests. So now we try to test the debugger as much as we can, even the GUI. And what I call invisible improvements, so infrastructural and architectural improvements, and a set of new tools. I cannot speak about the new tools now. There will be a small demo by Valentin, but I can speak about that more this evening. I just want to speak a little about what we improve in the infrastructure and in the architecture of the debugger. So on the infrastructure level, before, when you wanted to open a debugger, you have this kind of thing. So you have all the clients that want to open a debugger here, and they can choose how to open a debugger using various APIs there. And even some clients could just create a new debugger instance, opening and do stuff. And it was very difficult with that to track bugs in the debugger system, because we didn't know or did not understand easily why, for example, we open a debugger through process and through this strange API. So we tried to redesign this. So now all our clients, they use a single entry point here. And so basically, when you want to open a debugger, you create a request. That request, you configure it with the context of why you are opening a debugger. And this is the only means to open a debugger. This request is transmitted to a debugger system. It's an object that will look at the list of debugger in the system and choose one of the debugger to debug your context. Here, we introduce a trait that allows you to introduce your own debugger in the system. You just use the trait, you implement the interface, and then your debugger is automatically added on the system, and it can be selected and opened to debug your domain. And to select which debugger we open, we use strategies. So the purpose of that, because the default strategy is just open the Pharo debugger. But the point of this is that if you have, if you are debugging domain code, you can detect with a custom strategy that you are in a domain context, and then choose your own debugger to debug your domain context. And so globally, this works better. It's better understandable. It's easier to debug than the previous system. We did also some work on the architecture of the debugger. So the most difficult thing to do was to separate clearly in the debugger itself the GUI from the model, from the kernel, because before those three layers, they were mixed into the spec presenter, into the UI of the debugger. So we cut them in three, and there are still some glitches, but it works better now. And now, when you want to implement a debugger, you can choose to implement a new UI or to implement a new way of using the kernel. So we did that by implementing a debugger with Toplo. So Toplo, it's a widget framework based on block. And in less than 15 minutes, we built that debugger that So we just had to build a UI and plug in into the API, and it works out of the box. So we can debug with this new UI. That means we can build a remote UI and remotely interact with the local debugger model. So this is much easier to do that kind of stuff now. And the other improvement there is that we can easily extend all the parts of the debugger. So there are more tricky things like switching the interpreter. So you can do it. You can take the Pharo interpreter and replace it with another one. But you can extend everything that you see. So you can change the debugger layout, but this is not thanks to us. It is thanks to spec, because the spec in spec you can change the layout easily. It works out of the box. You can extend the debugger through meta programming. So there are different things that you can do. For example, you can create debugger extensions. This is what Valentin will present. So when you create a debugger extension, it appears here on the right. So this is a bytecode extensions. The extensions, basically, it is connected to the debugger itself, and you can read data from the debugging context, and you can act on the debugging context. So here we can step bytecodes, and stepping here has an impact on the standard debugger that is there. The other ways of extending the debugger is by creating new debugging commands. So for that, we use Sindarin. It's an API to control the interpreter, the bytecode interpreter. So with this API, we built new commands. So this is what you can find on the advanced step button. So you have different here debugging actions that you do not find in the standard toolbar. So this is an example scenario of work that stems from originated from our research that we integrated into Pharo. So just one example about these debugging commands. We built with that a jump command. So it exists in other debuggers, but it did not in Pharo. So in this debugging command, so it's an extension of the standard command. You are debugging this code, and you are currently here in the debugger, and for some reason you want to actually execute this other branch. But it's not necessarily easy to do, because you don't want to restart all your program. Even if you restart your application, you have no guarantee that you can force your program to go to this branch. So with this command, you can just place your caret where you want to go, click jump, and then the debugger moves the executions at this place. And so this is an example of what we can do with the extension commands with Sindarin. I cannot show more. There will be the demo, and I will show more or discuss with you if you are interested during the Tech Awards. What we want to do in the next year, there are a lot of things, but I will say that the most important are working on a better emergency debugger. So normally it's the debugger that opens when everything else fails, but apparently even this one fails, or at least it's not easy to use. So we want to start it over and collect user feedback. So I'm going to need to ask the community at some point, what do you want to see at the last resort when everything else fails? What kind of emergency debugger should we build? And there is ongoing work with Thales about redesigning the debugger GUI, and it's to improve the debugging experience. So I went a bit fast, but there is the demo of Valentin about creating a debugger extension.
All right, so as Steven said, I'm Valentin, a first-year PhD student at INERIA, and I'm doing my research on object-centric debugging. So I am now going to explain how to develop an extension for the Pharo debugger. First, let's have a look at the debugger itself. So the debugger contains all common features of debuggers. So there is a call stack, a code pane, and a context inspector, and all of those components are connected together. We can extend this default behavior if we want, thanks to the extension mechanism. And this mechanism allows us to integrate some tools into the debugger. So now let's say that we would like to integrate a profiler in order to get some performance statistics on a call that is selected here in the call stack. So we can use the actual time profiler, which is already present in Pharo, to integrate it and then use it as an extension into the debugger. Let me show you the expected results, and we will try to recreate the extension together. So to activate the extension, I have to click on this setting button on the top right corner of the debugger. It opens the settings browser, and after we have to go through the debugger extension list and look for the name of the extension we want to activate. Here it is the profiler expected results. If I tick the checkbox, it activates the extension, and we see here the new pane that is opened. So the profiler is only composed of a menu with a parameter that is required by the profiler and a button to start the profiling. So if I click on it, I expect to see here the results in a call tree on the report pane on the bottom of the extension. If I change the selection of our call into the call stack, it should refresh the extension. Now we can try to do the same thing, the exact same thing together. To ease the process, I have prepared a template class. So let me open it. So we will start from the template class. I copy the template in order to recreate a new extension. I rename it. We will call it my profiler, and I don't need template anymore. Okay. So here we have the class that will be used to declare our extension. First important thing to remember, it is that the class must extend SPPresenter. This is a class related to the UI development in Pharo. And it is important because the extension is actually integrated to the UI of the debugger. We also have to use the trait TST debugger extension, which is important for the system to detect the class as an extension of the debugger. Third important thing is to declare the name of our extension so that we can activate it through the settings menu that I opened earlier. So I'm gonna rename the extension to my profiler, as I said before. Okay, so now we should be able to activate the extension directly from the debugger. So I'm doing the same thing as before. I'm opening the settings browser, going through the debugger extension list, and here we can find the My Profiler extension, which is the one we just created. So I activate it, and it opens a new tab in the extension section. But there is nothing in our profiler, so we have to, of course, add the components of the profiler. As this part is related to UI development again, and especially with Pharo UI development with spec, I have prepared the code into the comments of the method we will implement. So the first method to implement is the initializePresenter method, in which we have to declare our components. So I will just uncomment the code. which is only using parts of the profiler. I declare every variables as an instance variable. So here we only have the profiler model, which is the class that will perform the calculation for us, and the two components, the menu pane and the profiler result pane. And we have to pass on the profiler model to the profiler result pane, so that when when we perform the calculation, it can update the results. And that's mostly it. After, we have to, of course, add our components to the layout. So this is also not very related to the integration of the debugger, but we have to do it because it is part of the UI developments that we need. So in the layout, we just add the menu pane and the profiler result pane on the bottom of the extension. So now, if we reopen the debugger, if I reopen the debugger, here, we should be able to see our components. Okay, so we have some UI glitches. It's not very important. But there is a button hidden here and the parameter here in the menu. But when I click on the button, which is hidden, nothing happens. It is because we have to connect the menu with the report pane to perform the calculation. So usually in spec, you have to do so. You have to implement the method connect presenters and specify the behavior required to connect the presenters together. So here, our first component is the menu pane, and when I click on the perform button, it should activate the code here that we can pass on the hook on profile do, which is present on the menu pane of the profiler. On the hook, we have two arguments, which are the context and the number of iterations that we selected into the menu. The context is the debugging context, so it's a variable that comes from the debugger. We'll see it more in details after. So when we click on the start button, we want to run the profiling of the method. And then we have to refresh the result pane, because when we run the profiling, it updates the model. So again, I will reopen the debugger so that it can take into account my modifications. And if I click on the start button, we have an exception. It is because the context here is nil. Of course, because we didn't connect the debugger, the default debugger, to our menu, so that our menu doesn't know the context yet. And when we pass the context to the profiler to do the performances calculation, it is still nil. So we have to connect the extension to the debugger variables. And this is the last very important part of this development. And it has to, for this, we have to override the update presenter method. So there is an example here. In the update presenter method, we have access to a variable which is named debugger. And from there, we can use the selected context of the debugger, which is the method call that we select in the call stack. And when we update the selected context, we now have to pass it to the menu, so that the menu can pass it after to the result pane, to the profiler. So debugger selected context. Selected context. Okay. So now, if I click on the start button, okay, I will refresh the debugger before. Sorry, I have many exceptions. Okay, now we have our results. But oh yeah, sorry, but it works. Thank you. And that is mostly it. Now, if you want to play with this code and try implementing your warn extension for the debugger, you can access this GitHub. And the name of the template is ST Debugger Extension Template Presenter, so you can access it as you want.
Any questions?
Not a really question. I was really impressed. It seems to be very interesting work. And yes, Schmidt funded it, so we like it as you made it. Just one simple addition to what I saw you do it before. I've seen a lot of code like this. Debugger, selected context, if not nil, and then comes the block. And then you refetch debugger selected context.
Yes.
I can tell you that can be a source of trouble that is very hard to find. So use the variable always in that cases. There's a lot of code in the old Pharo stuff that also has some issues like that. And I saw already some issues, especially in Morph and around there, where you have something, you think it's selected and I have it, and then you fetch it again and it's no more there for some reason. And that is very nasty. So always please think of that. Really use variables to keep the things that are important for continuing.
Okay.
Thanks.
So the problem is that the selected context can change or go away. But this is normal, because if you select another context, you need to refresh it.
Yeah, but if you have a variable that is not nil and it's important to pass it to somewhere, then take that variable and do not try to fetch it again. So that's
but the selected context normally it cannot be nil. You will have something selected into the.
Well,
so normally there should be tests covering that something is always selected.
Actually, it is related to the UI initialization, because the update presenter method is also called in other parts of the system when the UI updates itself. And so there is a risk that the debugger selected context is not there, and that's why I put the f not nil in the method.
So, anyway, you're right, but in the debugger code there are other nil checks like this, and on other cases, and the problem is finding time to track them and to eliminate them. And this is on our to-do list, but it's not on top yet of the to-do list. But this is true.
Thanks.
Other question?
Yeah.
Yeah?
Yeah, I have a comment maybe before. That's very cool.
Thank you.
This is impressive work. I have a question. Like you have several extensions about the debugger. Like, do you have something about differential debugging, or is it something you have investigated so far? Or?
No.
No, we don't.
So we should talk.
Thank you.